We will wait for 3 more minutes and then start the session. All right, so we'll start today's session. So, good evening, everyone. Welcome to week two problem solving session for the course C51 Natural Hazards. So, I hope you had a good day. So, we'll start the session without further ado. So, I'll be sharing my screen. Uh, Please let me know if it is visible to you or if it is not. So, I have shared the screen. Is it visible to you? I hope you can see this. All right, so yeah, as I said, the course is Natural Hazards, and the instructor is Professor Javed Malik from IIT Kanpur, and I'm the TA Anjana. So last week we had discussed regarding the basics of natural hazards. So we introduced the topic, and then we understood what natural hazard is, when it becomes a disaster or when it turns into a catastrophe. So this week we are getting into a bit more into the topics in which we'll be discussing about primarily about disaster management. So we know what a disaster is. So we need to know how we can act, or what all things we can do in order to minimize the damage that it is going to cause to the life and property. So that is what we are going to discuss today. So here I'm just briefly giving you you know a flowchart kind of thing to tell you what all kind of natural disasters are found in India. So as you can see, there are a vast variety of disasters that people in India experience, like the floods, which is like 12 percent of the land, whole land mass, it is prone to flood and river erosion. Similarly, earthquakes. So almost greater than 58.6% of the landmass is earthquake prone. Then comes the landslides and the avalanches, which are mainly found in the hilly areas. Then we have cyclones and tsunami along the coastal region. So we have, say, like 7,516 kilometer long coast, and out of which almost 5,700 kilometer is prone to disasters, natural disasters such as tsunami or cyclones. Then we have droughts, which is like 68% of cultivable area is affected by droughts. Then we also have the chemical, biological, radiological, and nuclear emergencies, because we have these nuclear reactors present over here. Then other man-made disasters. So essentially, we, as a whole, considering the size of our country, we experience quite a number of natural disasters over a period of time. So that is why I said, like, we understand that these kind of disasters happen in the country. So we need to understand what all measures we need to take in order to overcome these such situations. So the disaster management, it is essentially like, what do we understand by disaster management? So it is an integrated process of planning, organizing, coordinating, and implementing measures for the following. So what? Just imagine, like, you are in a place, and all of a sudden the earth, an earthquake strikes. So what all things you need to know? So if it is, if you're not aware of the things that you need to know, and you just run outside where the region is not an open space, it is surrounded by buildings, or let's say something, a tree or something like that, it's not an open area, so anything can fall on you. So if you don't know the fact that you should not run to a place which is filled with such buildings or such things, instead you should have run to an open area. So if you didn't know that, you would have definitely come under a building which is falling or something like that. So it is essential to to understand that there are certain measures that you need to take in order to overcome such events. So first thing is prevention of the threat. So if something is preventable, like if it is something can be prevented, do that first. So if there is an area which is very much prone to earthquake, and you're planning to build a home there, and so if you have an alternative option, you can build that home somewhere else, then do that, so that you can prevent your exposure to such a threat. Then suppose you don't have a place else, another place where you can build your home, it is only this place which is prone to earthquake, then the next thing that you can do is reduce the risk or consequences. So you should build a structure in which is compatible with such events, like compatible to shaking and all. So that is one way you can reduce the risk or consequences. So such buildings, and of course we'll be discussing this in detail when you have the lectures on earthquakes in detail. But then as an example, I'm saying in Japan and all, we have such structures in which the foundation is made in such a way that when an earthquake occurs, the building also shakes along with the earth's movement. So as a result, it will not cause any damage or collapse of the entire building. So such reduction of risk or consequences can be done. Then readiness and promptness in dealing with a disaster. So this is partly should be done by people and partly by the authorities. So suppose it was a very huge disaster, and people need to take some measures to reach to the affected people very quickly. So in that way, they need to have vehicles, they need to have I'm giving a lot of example from this earthquake part, but other disasters also. In any disasters, you need those material, man and material you require in order to promptly deal with the disaster. Then you have assessing the severity of disaster effects. So some cases it might not be very severe, so people can recuperate on their own. But in some cases it might be very severe that such camps might have to be set up, rehabilitation camps, all those things. So such things you have to be prepared for. So rescue and relief is important, and then finally rehabilitation and reconstruction. So once everything is damaged, the government, the people, they should be equipped in order to rehabilitate and reconstruct all those things which have been damaged. So this is a broad idea of what disaster management is. Now, management involves all these things. So, whatever I've said right now, the preparation, response, recovery, and mitigation. So, you have to be always be prepared in order to respond quickly. That's why it's like a cycle. So, everything is interdependent. You have to be prepared in order to respond, recover, and mitigate. Similarly, all these things, they're interconnected. So, disaster management, it is one of the most important activity which can reduce a total life loss and property loss. So if you would remember, like if you guys have attended the previous problem solving session, so I had mentioned whether it be a natural hazard, whether it be a disaster or a catastrophe, the bottom line is how much it is affecting the people, and the how much loss of life is there and loss of property is there. So disaster management is mainly to reduce that, the amount of people losing their lives, the number of uh, buildings or any such structures which are damaged. So all these things are a part of disaster prevention and mitigation. I'm sorry, I didn't make it as the full screen, so I'll be doing it right now. Okay. So the next thing is earthquake. So 70% of the world's earthquakes occur in the Asia Pacific region. So there are different parts in this across the world which are prone to earthquakes. So those are weak spots. So 70% of the world's earthquake, they occur in the Asia Pacific region, primarily in Japan, India, Nepal, Philippines, Iran, Afghanistan, and the Pacific Islands. So this is just few of the examples that I'm giving. This does not mean that other places don't experience earthquake, but when you look at a broader sense, then these are the regions. 50 to 60% of India is vulnerable to seismic activities. So the Himalayan region, which is, if you remember from last session, so as I said, the Himalayan region is primarily where the Indian plate is colliding with the Eurasian plate. So that is a point of where some activity is happening. It is moving against the Eurasian plate. So because of which that region is seismically active. Similarly, in the Andaman and Nicobar Islands, that is a subduction area. Subduction is when one plate is going beneath the other plate. One tectonic plate is going beneath the other tectonic plate. So that such areas are very much prone to earthquakes. So earthquake prone regions have been identified based on scientific inputs related to seismicity, earthquakes that occurred in the past, and the tectonic setup of the region. So when somebody, we have a seismic zonation map in India. So that map was prepared primarily based on these data. Like some scientific input is there in order to understand the seismicity of the region, like how much it is prone to earthquake. Then based on the frequency and number of earthquakes that have occurred in the past, and how the region is set up, like how tectonically it is present, like if it is active, if it is inactive. But of course, in regions which are found to be inactive, do you have any question? If anybody has any question, please do interrupt, like I don't mind. Okay. So, as I said, so based on the seismicity, based on the earthquakes which have occurred in the past, and the tectonic setup of the region, we are, the officials, they have prepared a seismic zonation map. So that kind of is a part of disaster management. So you can be, equipped in order to face a disaster such as an earthquake when it strikes. So, this is what I was talking about, the seismic zones of India. So broadly, it is classified into zone 2, zone 3, zone 4, and zone 5. So if you look at this diagram, you can see that zone 5 is marked by the dark brown or kind of reddish, right? So that color. So this one, you can see that the Andaman region is very much that dark in color. So it is marked as zone 5, which is the highest one. And this Himalayan regions also, you can see They are mainly coming under zone 5 or zone 4, not below that. So that itself tells you how much these regions are susceptible to earthquake. Even this region in Gujarat is also shown to be seismically active. Other regions are not very found to be very active, but then that does not tell you that these regions are not susceptible to earthquake. It can happen, so it's not that it doesn't happen, but then the chances are very less, that's all. Even this is a macro zonation, so it's like you are telling it in a broader sense, but then if you go state wise, then micro zonation mapping can also be done, so even minute areas will be taken into consideration. So some of the effects of earthquake. So what happens when an earthquake occurs? So first thing which everybody knows is that the ground will shake, right? So ground shaking. So magnitude, and that ground shaking depends on the magnitude of the earthquake. If the magnitude is very high, like say more than like 7, 8, 9, 10, like that. So if that is the case, the ground shaking will be very prominent. Like you can actually feel it and you can actually see it also. But at the same time, if it is not very higher magnitude, like it's a less magnitude earthquake, it you might just feel the slight jolt, but not more than that. So that's how one of the effect of earthquake, and it also depends on how much far that particular place is from the fault, and also the soil conditions. Soil conditions in the sense that if it is a soil which it's very soft soil, something like that, then that effect will be more. If it is more hard, then the effect will be less. It dissipates very well in a hard rock. So that's how. Then landslides. So landslide itself is a natural disaster, but then landslides can also happen as a consequence of earthquake. So what happens is, let's say there is a slope, okay? So that slope is already, let me just draw and show you. So let's say this is a slope. So this slope is already unstable. So like it's just waiting for some push in order to destabilize and fall down. So that push in this region was a earthquake. So when earthquake occurred, this region became unstable and all these things slid down. So that resulted in a landslide. So ground shaking can destabilize such slopes. So the Kaikoura earthquake, if you remember, Sir had discussed in the session, his lectures also. So the Kaikoura earthquake in 2016, it triggered several such landslides. So between like 80,000 to 1 lakh. So that's like a very huge number, right? So that is what I'm trying to tell you. Like if some slope is already like not very stable, uh, it's kind of on the verge of collapsing, and then an earthquake strikes, it can completely destabilize that slope and result, which eventually results in a landslide. So this brings us to the other effects like liquefaction, fires, and tsunami. So fires, as you know, like some short circuit can happen, any such incident, which is mostly natural fires can happen, but more than that, human induced fires can also be there. Then tsunami, which a good example is the 2004 Sumatra tsunami, which was due to an underwater earthquake. So that effect is there. Liquefaction is when the seismic waves uh, they cause the water molecules in saturated soil to become pressurized, and the soil particles begin to flow, behaving like a liquid. I have a good diagram after this, so I think you will understand it better in that way. And liquefaction can also result in lateral spreading. So on gentle slopes, which is gentle slopes is an means that let's say this is a steep slope, and gentle slope is when this is not very not at a very high angle. So this is steep and this is gentle. So it will be even more, say let's say it's like this instead of this. So this is more gentler, I guess. Yeah. So blocks of mostly intact superficial soil above the liquefied soil will collapse or slowly displace downslope. So I have a diagram for this one also. So I'll show you in the subsequent slide, which will give you an understanding what liquefaction is and the effect of liquefaction in the form of lateral spreading. So this is a diagram showing you about soil liquefaction. I think I'll show you, if possible, I'll also include a video of this in the upcoming lectures, which will be discussing predominantly on earthquakes. So in that, I can show you a video. Right now, I'll just explain with this diagram. So this tells you that, let's say this building is standing on a stable soil. Okay, so building is over here. It is standing on this top soil, and then here you have loosely packed grains of soil which are held together by friction. So whenever there are soil, this grains, sand grains, or like soil grains, so those particles, whenever they stay together, there is some pore spaces, some gaps are there in between. So in this situation, what they are saying is that gap is there, and it is filled with water, but it is stable. Like it is accurately filled with water, so there is no problem going on over there. But what happens is the shaking, which is a consequence of the earthquake. When that happens, it will destabilize the soil. So these particles will also move and increase the space between these grains. So when that structure is lost, the soil, so there is water and this grain is there. Earlier they were held together, and now when the ground shaking happened, they kind of pulled, moved apart. So when that destabilization happened, the structure is lost and the soil will flow like a liquid. So as you can see, this topsoil is intact over here, and here it is also intact. But when it came to the second figure where you have the liquefied soil, you can see that it affected the structure, and the building tilted, and it sank as the soil stability declined. It can collapse like this also. This is known as site effect. So it can just go down when the structures fail. So it is basically a consequence of the ground shaking. Then the other one, which I said, as a result of this soil liquefaction, what happens is, if you have a gentle slope, such phenomena can happen in which these blocks of this material on top of that liquefied soil will move down. So this is like blocks. It's not coming as a bulk, it is cutting into different blocks and coming down. So this, here you have a cohesive material, which is clay. Here you have the sand and silt with water. So this is the region which is liquefying. Okay, and then here you have the bedrock. So when this liquefaction happened, the overlying structure just collapsed, but it didn't collapse into like fragments, rather it collapsed in the form of blocks. So that is lateral spread. So I hope you understand what are the effects of earthquakes in this that I've discussed. So that is ground shaking is there, which we have discussed. Then we have the landslides. Then we have liquefaction, fires, tsunami, etc. And in liquefaction itself, we have another one, that is the lateral spreading. So this is the effects of earthquake. Then we'll just, Professor Malik has also discussed briefly on landslide. I think Sir will discuss this in much more detail in the upcoming lectures. But I'll just briefly summarize what he has discussed. So landslide is the movement of mass of rock, earth, or debris down a slope. So it can be anything. Okay, it can be soil, it can be rock, it can be anything which is moving down the slope. That is the like that process of phenomena is known as landslide. So this is common in hilly and mountainous area, especially in the Asia Pacific region. So as I said, you require some slope for this to happen. So it is common in hilly and mountainous areas. So the factors which influence landslide, what causes these landslide, that is the topography. So first thing is, it should have some kind of slope. So the topography plays a factor, like it should be hilly, or it should be with some slope it should be there. So topography is important. Then comes human activities like deforestation, cultivation, and construction. So as I said, when something affects the stability, landslide will occur. So that human activities like deforestation, cultivation, and construction can cause that loss of stability. So when deforestation happens, these trees which are present on the slopes, they hold the entire that material together. So the moment you cut them and put them away, then this that whatever soil is there, it is not able to hold together, it is not able to stay intact. As a result, it will slide down. Then rainfall, cloudburst. So in Kedarnath in 2013, the flood also happened, and along with that, several regions also experienced landslide. That was because of the sudden downpour. So much of water is coming that can destabilize the slope. So that is another influencing factor. And then, of course, as we already discussed, earthquakes. So earthquakes can also destabilize the slopes. This is again like this seismic zonation map. We have a landslide hazard zonation map also. So you can see here, this darker one is more prone to landslides. So that is also again closed, kind of similar to the seismic zonation map, right? So that is because of like these regions mostly experience landslides as a consequence of the earthquake. Also, monsoon can also be a result in this area, but primarily, if you remember the seismic zonation map, it is kind of similar to that. So, of course, even in this case also, even state-wise, they create such zones which are more susceptible to landslides. So this is an example of landslide in Munnar in Kerala. So you can see this, uh, this entire region, it kind of collapsed from here. So the reason to the left and right, they are intact, but at the same time, if you take a look at this, the entire slope just slid down. So if you take a look at whatever is present over here, you can see that mainly they have tea plantations here, and that tea plantation is not sufficient to hold this slope down. So actually, in place of this tea plantations, there should have been trees which could have reduced this much loss to life and property. But of course, because of this commercialization and everything, that didn't happen. And people are building their homes also. See, this houses come in the way of this landslide. So similarly, if there were houses over here, they are already buried. So we have to be very careful where you're constructing your homes, where you are doing cultivation. That is very much important. Then comes floods. So floods can be seasonal floods, so it can occur due to the seasonal rain that you have. Then flash floods, like sudden cloudburst is happening or sudden downpour is happening. So all of a sudden, flash floods can happen. Flash floods means something which happens in an instant. It's not like in seasonal floods, when it is raining continuously for a long period of time, then seasonal floods happen. But flash floods happens in an instant. Then urban floods is due to lack of proper drainage. So in Maharashtra, like in Mumbai, city like Mumbai or Chennai, most of the time these urban floods are happening because there is no proper drainage system. Then those which are associated with cyclones also. So urban floods, actually it can happen in case of all these three situations, seasonal floods, flash floods, or the floods associated with cyclones, because urban floods are bound to happen when there is a lot of water and there is no proper drainage. Then sir had also discussed about the 2008 Bihar flood. So what happened is that the Kosi River, okay, so just a moment. Yeah, so the Kosi River, uh, which experienced the shift to the western side. Okay, so westward shift of Kosi River happened during this 2008 Bihar flood. That happened over a period of 200 years. So about like 113 kilometers from the eastern margin, it moved towards the west. So what happened here is that, so what do you mean by river avulsion? Okay, river channel avulsion, you can say. So let's say a river is flowing like this. So it has been flowing like this for a long period of time, say like for centuries it has been flowing like this. Then due to some factors or some new river channel cutting through, what happens is this will slowly move in this direction. That was what happened in case of Kosi River. Okay, so it moved in the westward direction. So westward or any direction, what I'm trying to say is, if it moved in this direction or this direction instead of its actual path, which was this, so then we say the river channel has avulsed or river avulsion has taken place. So in case of Kosi River, this was what happened. So in August 2008, this Kosi River, it relocated by about like 60 kilometer to the east. And oh sorry, so it is an eastward shift, I'm sorry, so that was a mistake on my part. So it relocated by about 60 kilometers to the east, and a major flood about a channel approximately 20-kilometer wide started flowing. So what happened is, if it people they always take near this floodplains, because floodplains are very fertile. Okay, so it's like, because constantly water is coming, so it is very fertile. So you can always find people staying near such floodplains, not just Kosi River, almost all river nearby river channels people are staying. So in case of Kosi River also, people were staying on this floodplain, which was earlier not occupied by the Kosi River. So they never expected or anticipated that the river is going to move in this direction. They always knew in which direction Kosi River was moving. But in this particular time, that is in August 2008, people were not expecting this. So that is one of the reason why this became a huge disaster, because people, since they were not expecting it, they were not prepared for it. So as a result, it stranded hundreds of villages, it destroyed croplands, and it brought about disaster to thousands of people who were living in these areas. So this region, it was not considered flood prone as it was located far off the existing channel belt of the Kosi River. So people were, that was the last thing they expected that to happen. But unfortunately, it happened. Like, the Kosi River changed its course. So this is an image of that. So earlier, the Kosi River was moving in this fashion, like in this point A, through this point A, but then it shifted almost like 60 kilometer to point B, which was highly populated. Like, that region was populated, so people were largely affected, people and property. So it became a natural disaster. So now we'll discuss few problems related to this week, and then we'll also discuss the assignment problems from the last week. So kindly give your input so that it gets more interactive and it's not just me talking. So yeah. So the 2018 Sulawesi earthquake is the reason one in the Indonesian region that occurred on fault having what kind of movement? Does anybody know? A. Strike slip. B. Normal. C. Reverse. D. None of the above. What kind? Yes, yes. You're right. So the answer is strike slip. So the what happened is, if you have read it, or if you had listened to the lecture, you would have known the movement on the Palu Koru fault, strike slip movement happened. So the geodetic evidence, it suggests that about 150 kilometer of the fault ruptured, and I think this also resulted in a tsunami. It was quite significant. Then in US, the Dash earthquake with magnitude 7.9 moved the fault by 18 feet, and the pipeline above the ground did not face any damage. San Andreas fault, Denali fault, Palu fault, Hayward fault. Yes. So, do you know why Denali fault is, like, this particular example is important? So we have discussed about this disaster management, right? So this was a very good example of such a scenario. What I'm sure if you have listened to the lecture, you would already know, but still I'm just giving you a recap. So it is basically what happened is that the seismologist and the people constructing this pipeline, this crude oil pipeline, they kind of designed it in such a way that that pipeline was aligned along the Denali fault. So when it is along the fault, it will move along with the when earthquake moves, it will move along with it, or it will move along the rupture. So there is no significant effect on this pipeline. So they anticipated a movement of 20 feet and a magnitude close to what happened, like 7.8, 7.9. And that when that happened, the pipeline was able to withstand such a strong earthquake, and it just stayed put. So that's a very good example of disaster management taken by the authorities and the people constructing this pipeline. So that's why this example is important. The dash is recorded as the largest earthquake till date. So A is Bhuj 2001, San Francisco 1906, Gorka 2015, and Chile 1960. So which, no, like if you remember the diagram, you would know that Chile's magnitude is 9.5. So that is Chile 1960 would be the answer. There was a diagram, right? Like this or something. I'll have to check it. But yeah, so Chile 1960 is the largest magnitude earthquake till date. So in some volcanic eruptions, mud flows resulted due to snow cover are termed as. What do you call mud flows? Which are as a formed, as a result of snow cover melt. So that is debris flow, lahar flow, snow mud flow, none of the above. So what it essentially tells you is that in these volcanic eruptions, so you have a volcanic mountain, right? Of course, this will be discussed in much greater detail later on, but since he had mentioned it, that's why I have kept this also. So it's basically you have a, let's say, a snow-capped mountain, which is a volcanic mountain. So when this volcanic eruption happens, so what happens is that when the hot lava is flowing down, this snow will melt. Okay, so that snow, along with that melt, it will bring this other material and everything from this top, and it will bring it to the bottom. So what do you call that kind of flow? That is a mud flow, but in when it comes to volcanic eruptions, what do you call it? So it's known as a lahar flow. I think the same thing will be discussed again. So yeah, we'll have a recap then. So yeah, moving on to the next question. The most affected state from landslide due to heavy rainfall, deforestation, cultivation, and construction is A. Uttar Pradesh, B. Haryana, C. Kerala, D. Gujarat. You can just make a guess. Yeah. Any other guess? Like any other answers? Okay. Anybody else? Yeah. So the answer is Kerala. So mainly, a very good example is the 2018 Kerala flood also. So heavy rainfall was there, and then this cultivation has increased, construction has increased, and even I showed you an example from the Munnar region, right? So people, they cut down trees to such an extent that that entire slope has become unstable. So it's a very good example. Like other regions also experience disasters. That's, it's not that it's not the case, but then Kerala is primarily prone to such events because of these factors that we have just given. The flood, which is widely regarded as a result of anthropogenic activity, is A. Uttarakhand flood 2013, Mumbai flood 2017, Surat flood 2006, Brahmaputra flood 2016. Yes, yes. So the answer is Surat flood 2006. So Surat flood, which happened in Gujarat, so that was mainly kind of a result of human lack of human, action at the appropriate time. So they kind of waited and waited, and when they opened the dam gates, this kind of resulted in a flood. So that is a good example of the anthropogenic a flood which resulted as a result of anthropogenic flood, anthropogenic activity. So now we'll discuss the week one assignment. I'm sure you already have answered it, but those who might need some help understanding the answers, so that's why I've put it here. So when two tectonic plates move away from each other, then those are called dash plate margins. So just imagine two tectonic plates are moving away from each other. So what do you call such plate margins? I'm sure you have already submitted your assignment, so you can just give a guess. Like I have not put the options here because you might have already done it. All right, so I'm sure you might be knowing it anyway. So the answer is constructive plate margin. So if you remember from the previous class, so I had shown you this. So let's say this is a tectonic plate which is moving in this direction. Okay, and then you have another tectonic plate which is moving in this direction. So what will happen when they move towards each other? So let's say this tectonic plate is denser and this is, compared to this, it is lighter. So what will happen when this tectonic plate and this tectonic plate move towards each other? Can anyone tell me? Those of you who had attended last session also, I had explained this, so you can just give it a try. Like what will happen when these two tectonic plates move towards each other? This one is lighter compared to this one, so this is denser. So what will happen? Okay, so I think some of you might be knowing, and for those who don't know, so I'm telling. So when this is denser, so what happens is, now I have drawn a three-dimensional diagram over here. It's a bit difficult, so I'll show you it in a two-dimensional factor. So what happened is that this plate, which is lighter, will stay like this, and the heavier one or the denser one will go beneath it, and this process is known as subduction. So this one will go underneath and this will push against it. Okay. So when this happens, you can see that this, it is getting destroyed. Some destruction is happening. So these plate margins, they are called as destructive plate margins. So those plates which move towards each other, we call as destructive plate margins. So then what will happen when they move away from each other? Nothing is happening, right? They are not having any kind of interaction. They are moving away from each other, and at the same time, a good example is the mid-oceanic ridges. Okay, so let's say it's mostly, yeah, so this plate is moving in this direction and this plate is moving in this direction, and some, through this gap some magma is coming out. Okay, this is magma coming out. So when this magma cools down, it will solidify and it will become a part of that crust. So it is adding to the crust instead of taking away from the crust. So as a result, those in when two tectonic plates move away from each other, they are known as constructive because they, something is added to it rather than taken away from it. In this case, it is taken away. That is why we call it as destructive plate margins. In this case, they are added to it. So we call it as constructive plate margins. So I hope you understand that. That is a very basic part of this, tectonic, uh, plate tectonics part. Then we have dash effects, a thin band of country rock around magmas and molten rock and occurs at high temperature. Can anyone give me the answer? This is exactly your last week's assignment, like week 1 assignment. We are not supposed to discuss the same questions of the in this session I cannot discuss the week 2 assignment, so that's why I'm just revising the old one. So those who know, kind of, you can just give your input. Okay, I hope some of you might be knowing this anyway. So the answer is contact metamorphism. So I have a diagram here. So you can see this part, this lighter, the skin colored part, that let's say we like it is known as the country rock. Okay, so this country rock or anything, like only thing you have to understand is that this magma, when it comes from beneath the interior, from the interior, and when it has an interaction with this this rock which is surrounding it, so magma is very hot and it is coming, it is at a very high temperature and it is coming out. So that high temperature will cause some changes in this contact zone, where this magma is having a contact with the country rock or the rock surrounding it. So that is known as the contact aureole, and this change that rock is experiencing, that is known as metamorphism. So contact metamorphism, wherever that change is happening, we call that region has experienced contact metamorphism. So that is the example. This was discussed in the week 1 lecture. So it had already shown you a diagram also on this. The dash thrust fault system is the result of collision between the Australian and the Pacific plate. So what is the example of that? The thrust fault system. Anybody? No. Like there is a thrust fault system which is formed between when so I have discussed this one, no, uh, here. So when they come close together, uh, this lighter plate will stay intact and the denser plate will go down. Now let's say if this both of them are of comparable density, like there is no density difference, then what happens is instead of going down, they will collide and they will push that whatever material is at the point of collision, they will be pushed up. So a thrust fault system will be formed. So that example in this case, that like between Australian and the Pacific plate, is the alpine system. So alpine mountains, if you have heard, they are a result of this collision between the Australian and the Pacific plate. Can you tell me an example of this similar scenario in India? Anyone? Yes. So Himalayas formed between like the collision between which two plates? Like Australian and Pacific plate, there are two plates which resulted in the formation of the Himalayan orogeny or Himalayan thrust fault system. Not exactly. Like when you talk in terms of plates, in this case, it is the Indian plate and the Eurasian plate. Okay, so yeah, if you just a moment, I'll just show you. I think I have a diagram later on, but still I can just explain it here. So let's say this is the Indian map, right? So as I said, in case of the seismic zonation also and in case of landslide hazard zonation, you can see it is more predominant in this region, right? So I'll just draw with this pen. So you can see it is very much predominant in this area. So this area is experiencing that because this Indian plate, it is pushing against the Eurasian plate. Okay, so the Eurasian plate is here and the Indian plate is pushing against it. So that point of contact is actually, it's not just a line like this, it's in a huge area. Okay, so this area, it is experiencing some kind of push because of the collision of these two plates from either side. What happens is this resulted in the formation of the Himalayan orogeny. So that Himalayan mountains you can see in this area, and it is still, that thing is still going on. So as a result, this region is very weak and it is susceptible to earthquakes, and also as a result, it can also lead to landslide events. So that is why this area is very sensitive. This area is a collision zone. Similarly, if you consider the Andaman and Nicobar Islands, so that is part of this subduction system. So in this case, one plate is going down the other. So this area is also very much, seismically active. So these two are very, good examples of seismically active regions in the Indian subcontinent. So that, yeah. So we have discussed about the alpine system. So the next one is uh, human eyes are susceptible to wavelength range of about dash micrometer. Or you can just tell me the region in the electromagnetic spectrum, like which region the human eyes are susceptible to. I hope you understand the electromagnetic spectrum. I had shown an image in the last discussion, I think. Yeah. So, like, what all, which part of that electromagnetic spectrum as humans, we can see with our eyes? Any idea? Okay, so as I was saying, we have this electromagnetic spectrum, right? So, okay, the answer is zero point 0.4 to zero point 0.7 micrometer or 400 to 700 nanometer. Either way, that is coming under the visible range in the electromagnetic spectrum. So, what is an electromagnetic spectrum? So, we have, different kind of, radiation, electromagnetic radiation or electromagnetic spectra. So here, a very easy method to remember this is, I've mentioned in the last session also. So you have C, G, X, U, B, I, M, R. Okay, so this is CGX, UV, IMR. So it's an easy way to remember the electromagnetic spectrum. So what these mean is that C stands for cosmic rays, G stands for gamma rays. So these are different, you know, like light. When you say light in broad sense, that comprises of all these things. So cosmic rays is there, gamma rays is there, then we have X-rays, then we have ultraviolet or UV rays, then we have the visible rays, which is actually what I'm talking about. So this comes in the visible range, zero point 0.4 to zero point 0.7 micrometer, which the human eyes can see. Now these animals, I don't know exactly which part of the spectrum they can see, but yeah, it's not same as human. So whatever we see is not what, let's say, a dog sees. So the dog is not seeing a particular thing in the exact same color or shade as you are seeing that. So that comes in this, like what we see comes in this visible spectra or visible region of the electromagnetic spectra. I stands for infrared, M stands for microwave, and R stands for radio wave. Now, an interesting thing is that when you move from this cosmic rays to the radio waves, the wavelength increases. Okay, so from here to here, when you go, the wavelength of that particular ray or radiation, it increases. So wavelength is represented by lambda. So lambda increases in this direction. And if you consider the visible rays, and if you think about your, let's say, rainbow, so we have the VIBGYOR, right? So violet will have the shortest wavelength, and or let's say blue. So blue has the shortest wavelength, and red has the uh, longest wavelength. So red can travel much longer distance when compared to blue. So all this comes in the visible spectra. So human eyes can see the visible region of the electromagnetic spectrum, and that range is 0.4 to zero point 0.7 micrometer. I'm just telling this as for your information. I don't think you need it in this detail. But if at all such similar questions from a different, if they ask about a different part of the spectrum, then that will be easier for you. So that's why I just discussed it. This is just an easier way to remember it. If it is, you have some other method, that is also fine. So in May 2020, the east coast of India was hit by a cyclone. Like, you need to give me the name of that cyclone, which formed due to intense low pressure overseas. So what is the name of that cyclone which hit the Indian coast in May 2020? Any idea? Which name? No, the answer is Amphan. Okay, yeah. So the answer is Amphan. So it's not just Amphan, any cyclone which is formed, which hits the coastline of any place, let's say, it is formed by intense low pressure, which this I discussed in the last class also. So it is a result of low pressure, which is generated in these seas, like in our case, in the Arabian Sea or the Bay of Bengal. So when such intense low pressure is formed, that strikes the coast as a cyclone. The Dash earthquake occurred on 14th November 2016 in between the Pacific and the Australian plates. So it's a very general question. You don't have any phenomena directly to explain. So what is the name of the earthquake which occurred on 14 November 2016 between the Pacific and the Australian plates? It's a question from your assignment, that's why I put it like this. Otherwise, it's a very general question, so I don't think I'm required to discuss this. So the answer is Kaikoura. Okay. So the Kaikoura earthquake occurred on the 14th of November between the Pacific and the Australian plates. A tropical cyclone is an dash area in the atmosphere over tropical or subtropical waters. So this I just now said. So like what condition is required for a cyclone to form? Just in the previous one we have discussed this. So just think about it. Like what is required for a cyclone to form? Yes. So we need a low pressure area. So intense low pressure is required for a tropical cyclone to generate over the tropical or subtropical waters. Earth approximately falls in the dash system as there are few meteoritic impacts, and that causes a slight escape of gases into the space. Like there are three type of systems, right? Open, closed and isolated system. So Earth comes under what system? Yes. So the answer is closed system. So if you remember, a closed system is the one in which matter can go out, like exchange of matter can occur, but there is no exchange of energy. So that is a closed system, and that is Earth is approximately a closed system because, oh sorry, it is like a closed system is it can exchange energy but matter cannot go out, right? I'm sorry, that was a mistake on my part. So energy can be exchanged in case of a closed system, but matter cannot be exchanged. But Earth is approximately a closed system because of this. Occasionally, Earth will be subjected to meteoritic impacts, and when that happens, some amount of these atmospheric gases they escape into the space. So as a result, we call Earth as a approximately closed system. The other systems like the open system that exchanges both matter as well as energy. So that is like completely open. It can exchange the matter like materials and also the heat or whatever in the form of energy. And isolated system doesn't allow anything to go out or inside. So I had given you examples also. Isolated system is equivalent to a flask of hot tea. So if you put a tea in a hot flask, on the outside of that flask you don't feel the heat, right? And neither the tea is losing that heat, and whatever tea you had poured in that flask, that is intact. So it's a very good example of the isolated system. And closed system is let's say the same tea you are keeping it in a normal container, so you can feel that heat on that container surface itself, right? So energy is exchanged, but then matter is not exchanged because it is closed. And then open system means any system which is open, like just like that, it is sharing, it is exchanging all this matter and the energy like heat or cold, whatever it is. So it is exchanged. Vulnerability to natural hazards has increased in many coastal areas due to the loss of dash that provide natural protection from marine flooding and even tsunamis. So, what protects the coast from such events? Yeah, that is like part of the answer. So you're right only. But broadly, when you say, we say it as the coastal habitat. So including mangroves, then we have this coral reefs. So different, habitat that is formed. Just a moment. Yeah, Arman, I'll recap the entire thing. Just give me a moment. Once we complete this discussion, I'll recap it. All right, so that's what I was saying. Like as you said, mangrove is right only, but then along with mangroves, other habitats like the coral reefs or any other, animals or whatever naturally it is built along the coast, they will protect us from the impact of the flooding or tsunamis and all those things. So when these habitats are disturbed or when they are destroyed, we are not protected in a as good as we would have been if these were intact. So coastal habitats are very important. They need to be protected. This brings us to plate tectonics. So yeah, I'm just briefly discussing it over here, but then we can have a much more detailed discussion based on how you're understanding these things and how much you want me to discuss. So this is just a basic thing for you to get a gist of what plate tectonic is. So the Earth's surface, if you take a look at that, we have a number of lithospheric plates. So large broken pieces of lithosphere that move relative to one another. So if you consider this as the Earth's surface, okay, so we have what, I'm not drawing it very properly, but yeah, so what they're trying to say is the surface is made up of large lithospheric plates. Now you have to understand continents and plates are not the same thing. Okay, like yeah, we have plates in the name of these continents, that is true, but the area that it is encompassing is not the same. So lithospheric plates, they are large broken pieces of lithosphere that move relative to one another. So one is moving and they relative to that we'll determine the velocity of the other. So the processes associated with the creation, movement and destruction of such lithospheric plates, together we call it as the plate tectonics. So when you say the study of plate tectonics or when you say the field of plate tectonics, what it essentially means is how, you know, the processes which are associated with the creation of such plates, the movement of such plates and the destruction of such plates. So creation is essentially pointing to the constructive plate margins. Movement is how they are moving towards each other, away from each other, at what velocity they are moving, those things. And destruction is related to this collision or the destructive plate margins. So the entire, these three things will together, collectively we call it as plate tectonics. So that is what plate tectonics means. I hope you understand that. So this is a good image showing you that. So that's why I was saying we have the North American plate over here. Then we have the Juan de Fuca plate. So see, these all are plates, and these ones which are showing these red, pointed things along the border, that is, they are the convergent margins or the destructive plate margins. So here it is subduction is happening. Okay, subduction or collision is happening. So in India you can see where you have the Himalayas, we have this convergent plate margin. In the Andaman, close to the Andaman region, we have the convergent plate margin. Here you have the divergent plate margin or the constructive plate margin. Then we have the transform plate boundary. Like there are numerous different uh, plate margins that you can see across the globe. So you have the North American plate, you have the African plate, you have the Indo-Australian plate, or if you consider here, you have the Indian plate. So Indian subcontinent moved from the bottom till this top. So that kind of thing. So you have a different number of lithospheric plates present. not just these bigger ones, we even have smaller ones also, like Cocos Plate, Joandifica Plate. So bigger ones, I think mainly you have seven plate, you know, tectonic plates, and then you have smaller ones like this Cocos Plate, Nazca Plate, and all. So if you see, just keep in mind all these plate boundaries, just visualize them, and then when you come to these this map, you can see wherever these plate boundaries are there. Okay, so let's say for example we'll take this region. Okay, so the North American plate, Joandifica plate, all these things. So here I'm taking. So if you look at the same area, so look at the same area in the next map. Okay, so see, it is very much active. So that's what I've written here. Plate boundaries are geologically active areas. So they are very much geologically active, and these regions have volcanoes and earthquakes. Now I don't know if I've included it in this one, but if you are interested in the upcoming lectures, I'll tell you like how exactly this is happening. So here you have the volcanoes, which are depicted by the red triangles, and then you have the earthquakes. Same thing if you look at this region in India. So you remember seeing that red line here, no? So here you have the uh, large number of earthquakes happening, and this region in near Andaman, earthquake and this volcanic eruptions are shown. So you have to understand that these plate boundaries are very much geologically active, or they are geologically active regions. So continental drift hypothesis, uh, that is how like you have to understand that earlier when this continental drift hypothesis was told by Alfred Wegener, it was not actually, people didn't have an access to see across the globe to see what was happening. He took some evidences from across the globe in order to say that the continents, now wherever they are, that position was not intact, like they were in a different place in the past, and they will be in a different place in the future. It's not that the place that these continents are present are not are like fixed. They are not going to stay here for a long time, they are going to move. So this in 1912, Alfred Wegener, he was a German meteorologist, but then he noticed that the east coast of South America and the west coast of Africa, they seem to fit like a jigsaw puzzle. So the east coast, if you look at this diagram, so this is the east coast of South America, and this is the west coast of Africa. So if you can see, it's not exact, but at the same time, if you bring this part to this region, they will fit together like a puzzle. So you have played with these jigsaw puzzles, right? So how two puzzle pieces connect with each other, like that this part of the South Africa and this part of South America, when they are put together, he found that they seem to connect with each other. So that was an evidence for him to say that there is some kind of connection between these two regions, despite the fact that they're separated by the Atlantic Ocean in the present. So Atlantic Ocean is very vast. So you're seeing America in one end of the Atlantic Ocean and Africa in the other end, and yet there are some similarities. So how did this happen? That is what prodded him, what made him to prod further into this topic. So which brings us to Pangea. So that is all land masses which are present, which are present right now. They were originally united into a single supercontinent. So right now we have like seven continents. So what he proposed is that one time in the past, all of these continents were a single landmass, single whole mass together, and then over time they split apart and came to the position that they are in at present. So at the time, there were no known mechanism that could explain this hypothesis. So he could say this, but he couldn't provide any proper evidence for this. Like it was just whatever he could visualize. There was no evidence to give in terms of this continental drift hypothesis. So this is what he was trying to tell, like 200 million years ago. So you have to understand this is a geological time. Like for a human being, our maximum we'll think in terms of 100 years, right? But when you talk about the Earth formed like 4.5 billion years ago. Billion means 10 to the power 9 years. That's like a very huge, long time back, right? So in that, 200 million years is just a small fragment. But even then, 200 million years ago, the whole of the globe, if you look, it was a single huge landmass instead of the current uh, position of each of the continent. All of them were together at that time. And then like 135 million years ago, so like after 135 million years, this Pangaea, they kind of broke into Laurasia and Gondwana. So Laurasia came in the north and Gondwana came to the south. So India was part of this Gondwana land. Okay. So Pangaea was there. It broke to Laurasia and Gondwana. India was a part of Gondwana, and then India, gradually it moved in this direction. So South America moved in this direction like 65 million years ago. So South America moved in this direction, India moved in this direction, and eventually it collided with this Eurasian plate. Antarctica moved further south. Australia moved a bit in this direction. So this is how they separated and came to the present situation. So it's not that they were in this condition all throughout the time. That is not the case. They were initially all together and then they broke apart. So they're still moving. That's what I'm telling you. Like this Indian subcontinent is still pushing against the Eurasian plate. So if that is the case, maybe eventually India might move further, towards the north rather than where it is right now. Now it is closer to the equator, but over time it can move away from the equator. So that is what tells you about this continental drift hypothesis. So the evidence that people provided for this continental drift hypothesis is, the first one is continental fit, which Alfred Wegener also said. So you can see this is this part of South America, you can fit it exactly with the African part. So that is one example. So continental fit. So similarly they found other examples in terms of Antarctica, India, Australia. So based on that, so that is one evidence, is the continental fit. Okay, so continental fit. Another evidence is the similarity of rock sequences and mountain ranges. So, what they did is that they kind of checked the ages of rocks that are found along these, margins. So, they found that their age is very much similar. So, identical age for marine, non-marine, and glacial rock sequences on all the five, like Australia, Antarctica, South America, Africa, and Madagascar. So, what it tells you is that all these these parts, continents, they were part of the Gondwana land because their age is very much similar. So that was a good evidence for the continental drift hypothesis. Then the folded northeastward trending Appalachian Mountains of North America extended through the eastern United States and Canada and has an abrupt termination at the Newfoundland coastline. Mountain ranges of the same age and deformational style are found in eastern Greenland, Ireland, Great Britain, and Norway. So it might be a bit difficult for you to imagine that. So what I'm trying to tell you is the Appalachian Mountains. So this is the Greenland part, and then you have the Scandinavian countries also towards here. So what they're saying is the Appalachian Mountains, they extended till this. Um, Along till this Canada, but then it abruptly stopped. And then they found this similar mountain ranges of similar ages in the Greenland region. So that all these things are evidence that they were once together and then they split apart. Another evidence is the glacial evidence. So what happens is, you know what glacier is, right? So that is like people who have visited regions with snow and all, you will know. So in case of glacial deposits and striations, they indicate the massive glaciers covered large areas of the Gondwana continents during the late Paleozoic era. So regions which didn't have, uh, snow right now, like there is no snow at present in that area, but you're seeing markings like this. These are known as glacial striations. Glacial striations are formed when the the snow, like glacier, when it moves down, it will pick up the rocks that are present in the ground. Okay, so what happens is this rocks will be kind of stuck to the bottom of this glacier when it is moving in an area. So this rock pieces, they will create such marks on the bedrock or whatever rock is underlying. It will create such marks, and these are known as glacial striations. So these are good evidence, glacial evidence, to tell you that uh, the region which doesn't have snow right now, it was once in an area which was filled with snow. So in this case, the example was seen in Gondwana continents. Like the example that India and Antarctica were once together, or Australia and Antarctica were once together, such glacial striations are a good evidence for that. Another example is the fossils, the Glossopteris flora, which is a kind of a flowering plant that was found in all these Gondwana continents. So such plants had large seeds that could not have been carried by wind. So one thing is that if you see similar plants in nearby areas, then people can say that the wind brought it. Okay, wind brought the seeds, and then that seed fell, and the plant, it grew. But then, in case of Glossopteris flora, this seed is very big, because of which it cannot be carried by the wind. So, if you find the same plant remains in five different continents, Gondwana continents, the only explanation is that at one point of time in the past, all these were together. Like all these continents were together, because of which you can find the Glossopteris flora remnants in these five Gondwana continents. Another example is the Mesosaurus fossils. That is a freshwater reptile like this dinosaur and all. Like that's a species, a kind of a type of dinosaur. So dinosaur fossil. So that was found in Brazil, which is part of South America and South Africa. So in these two regions, they found these fossils. So from that, they understood that these two regions were together once before. So this is a diagram showing whatever I've told you right now. So this not just Mesosaurus, even this Glossopteris, it can be found in South America, Africa, India, Antarctica, and Australia. So all five continents, you can see that this Mesosaurus is similar to Mesosaurus and the Cyanonathus. So they are similar than Lystrosaurus. So these evidences are something which cannot be ignored. So they kind of tell you that the continental drift hypothesis as proposed by Alfred Wegener is true. So the explanation for drift theory came in 1960s because of the discovery of seafloor spreading. So this I don't think I have to dwell into more. But yeah, the idea is that the seafloor spreading was understood, and then based on certain paleo magnetic studies, people kind of gave a scientific explanation. Like other evidences were there, but a much more scientific evidence was given in the 1960s to explain the continental drift theory. So, as you already know, and as I've already discussed, there are different plate boundaries. So, we have the divergent plate boundary, we have the convergent plate boundary, which is of mainly three types, and then we have the transform plate boundary. So, divergent plate boundary is mostly related to oceanic crust or oceanic tectonic plates. So, what happens is basically two plates are going away from each other, divergent. Okay, so it's moving away from each other, they're spreading, and molten rock will come in between to fill this gap. So as a result, it is forming something new, which is why we call it as constructive plate margin. So example is mid-ocean ridge forms. And then convergent is, it can either be between an ocean and continent plate, it can be between ocean plate, or it can be between continent plate. It can be any of these three. Only thing is that when it is ocean continent or ocean, mostly the denser plate will sink, and the heavy lighter plate will stay on top. which will result in the formation of a subduction zone which is highly tectonically active. In case of continent, neither plate is dense enough to sink into the asthenosphere, so the compression will happen. As a result, this alpine, the mountain, the thrust system, like the alpine thrust system or the Himalayan thrust system, they form. Then transform is the one in which the plates just move past each other. There is no creation or destruction of anything. So we call it as the transform plate. However, in these regions, earthquakes are bound to happen because this movement is there. So earthquakes will form, but then there is no loss of land mass in such plate boundaries. So this is an image showing you the continental breakup. So you can see when two plates are moving away from each other, they will just pull apart. So just imagine this region was intact. Okay, so let's say uh, it was intact like this, and then because of some weak fault systems generating, they experience this stretch. Okay, so when and they start moving away from each other. So when that is pulled apart, a weak zone is formed in between, and these are known as fault blocks. So these are weak zones. We call it as Horst and Graben, but you don't need to get into that detail. So these are fault blocks, and then in this region, which is uh, the weak zone, the magma from beneath will come and it will solidify over here. So there is nothing is lost. Like, although this is broken, when the magma comes and solidify over here, nothing is lost. So this is continental breakup. So this can result in the formation, eventually it can result in the formation of ocean basins. So what people are saying is this Red Sea that you have right now, that can eventually turn into an ocean, because that is a rift valley actually. And even Rift Valley is present in the African Rift Valley, East African Rift Valley. So eventually that all that can become a part of an ocean, instead of what it is right now. Now it is part of a continent, but after a long period of time, that can turn into an ocean. Then comes the oceanic subduction. So this I've already discussed, so I don't think it is needed, but still, this is between two oceanic crust. So the denser one will go down and the heavier one will stay up. So what happens is when the denser one goes down, the whatever rock is present here, that is subjected to high pressure and temperature. So as a result, this will rise up. The magma, whatever is there, it will melt, it will rise up, and it will form a volcanic arc. So in case if it is two oceanic crust coming together, it is called as an island arc. And if it is when you have a oceanic and a continental crust coming together, then you have a continental arc system, or a volcanic arc system present. So this example you can see in case of the Andaman Islands. So there you have volcanoes as a result of subduction, and it results in the formation of the trench. So if you are familiar with the Mariana Trench, so that's the deepest trench, you can say, like very deep, so deep that if you keep the Himalaya, like the Mount Everest, if you take and keep this Mount Everest inside the trench, it will still be submerged, because Mount Everest is close to 8 kilometer height, and then this Mariana Trench is like close to 11 kilometer deep. So it will still be underwater. So you can imagine how deep this trench is. So such trench system is also a part of the subduction, oceanic subduction. Then comes the continental collision, which happens between two continental crusts. So this I've already said, two plates will come together, they will collide, and as a result, it will form a thrust system. So you have a mountain range like this, which is present. So that is regarding today's lecture. So if those of you who have any question, you can ask me, or for those who have joined late, I'll just briefly tell you what the topic was for today. So we were discussing that the natural disasters that are found in India. So we have the floods, we have the earthquakes, we have the landslides, cyclones, avalanches. So we have all kind of disasters in different parts of India, and since we are aware of these natural disasters, we need to know how we should take care of such situations, because they're unavoidable, right? They will frequently happen, and there is no other go. So you have to it's something which is unavoidable. So as a result, we need to know how to manage it. So that is known as disaster management. So it's an integrated process which is associated with the planning, organizing, coordinating, and implementing the measures. So this is basically it involves preparation. So you have to be always be prepared for such an event. Like if you know that area is susceptible to flood, or if you know an area is susceptible to let's say earthquake or landslide, so you need to be prepared in case such an event happens, and what all things you need to do. So that's a part of the preparation that which occurs before the impact. Like before the disaster strikes, you need to be prepared. Now if the disaster strikes, like if the disaster happens, then you need to respond quickly, right? The people who experienced it and the people who can help them need to respond quickly. So that comes under the emergency part, and also the restoration part. And then once you respond, you need to recover, right? So if people are stuck in some areas, they need to be rescued. uh, then all kind of health care must be undertaken, and then recovering your possessions, all those things. So that's part of the response and recovery. And then mitigation, like you have to uh, for example, mitigation in the sense that if you say an area is prone to earthquake, then you need to build structures in such a way that they can withstand such impacts in the future. So that's part of the disaster prevention and mitigation. Then, as you know, 70% of the world's earthquake, it occurs in the Asia Pacific region. So actually, this you can see in the diagram also, which I have discussed towards the end of this discussion. So yeah, so if you look at the Asia Pacific region, you can see uh, there are multiple earthquake events and volcanic eruptions. So this region, 70% of the earthquakes occur in these regions across the globe. So Japan, India, Nepal, Philippines, all these countries, they experience it. And in India, mainly the Himalayan region and the Andaman and Nicobar Islands are susceptible to such earthquake events. Then we have the seismic zones of India. So in India, we have different seismic zones. So we have the zone 2, zone 3, zone 4, and zone 5. There is no zone 1 as of now. We say broadly they are classified into these four zones. So you can see that this region in Jammu Kashmir, Himachal, like wherever you find the Himalayan thrust system, that is susceptible to largely susceptible to earthquake, because that there is still movement going on. And then in the Andaman Nicobar region also, because as I said, that is a subduction zone, so that is also susceptible to earthquake. And this is a macrozonation. Depending on the state wise or district wise, the microzonation is also done. Then effects of earthquake, ground shaking is there, which is the prominent effect that everyone knows. Like you experience the shaking of the ground, right? Now that depends on the magnitude of the earthquake. So if magnitude is not much, you might not feel it, but magnitude is high, you will actually experience the ground shaking. Then distance from the fault, how far it is away from this point of origin, and what is the soil condition. Like if soil condition is like it's a very soft soil, that whatever shaking you are experiencing, it will be very high compared to a person who is in a region which does not have that much of a soft soil. Then landslide is a consequence of this ground shaking. So if a slope is already unstable, then this ground shaking will destabilize the slope. And then in the questions also I will discussed, Kaikoura earthquake has triggered several such landslides. So 80,000 to 1 lakh uh, uh, landslides were uh, the result of the Kaikoura earthquake. Another effect is the liquefaction, which also results in the lateral spreading. So liquefaction is like I can show you the diagram. So it is basically when you have the soil grains that are uh, evenly distributed and no, not very compact, but then loosely packed grains. And they have this water in between their gaps. So it's not that each grain is stuck very close to the other. So this whatever gap is there, some water is present there in the pore space. And then when ground shaking happens, it kind of destabilizes these soil grains and they will move apart, which results in increase of space between the grains and the structure is lost and the soil will flow like a liquid, which is why we call it as soil liquefaction. And when this happens, this structure will, as you can see, it tilted, and this structure, it just collapsed like this. So this is also known as site effect. So this is soil liquefaction. A consequence of the soil liquefaction is the lateral spread. So lateral spread is when the material overlying is very rigid, or it's not very easily broken, but then the material underlying it is experiencing the liquefaction, so it will pull this material on the top, so it will collapse in the form of blocks rather than fragments. So it will come down in these block shape. So if you have seen certain regions like this, I think the Kutch earthquake in 2000 or 2001, that led to lateral spreading in numerous places. So we have such cracks in the ground, blocks of such material in the ground in different areas in Gujarat. Then landslide, as you know, it is the movement of mass of rock, earth, or debris down a slope. So you have a slope. Uh, so anything you keep on a slope is already very not very stable, right? It can fall down at any moment. So even then, if you have some material there which is it just stays there, but then when some movement happens, some destabilization happens, this material will come down. So that movement of mass of rock, it can be rock, it can be earth or debris, it can be a combination of all these down the slope. So this is mostly found in hilly or mountainous areas. Influencing factor is the topography. As I said, you need to have a slope. Then deforestation, cultivation, and construction can result in this landslide. Then rainfall or cloudburst, which a good example is the Kedarnath 2013 flood event, where you had numerous landslides happening. Then you have the earthquakes. All these things can result in the uh, landslide. And just like the seismic zonation map, we also have a landslide zonation map. So you can see again, as I already said, this region is very much susceptible to landslide also as a consequence of the earthquake. So this is an example of landslide which happened in Munnar in Kerala. So you can see you have tea plantations over here, right? On either side where the landslide has occurred. So this region was also having a tea plantation. So the problem is that on slopes, if you do not have trees or if you cut down trees, what happens is the soil will lose its ability to hold together, because the roots of the tree was the one that was supporting the soil. So now that trees are gone, and in place of the trees you are putting in plantations like tea, the roots of the tea plantations cannot hold it as properly as the ones as the ones in case of trees. So as a result, this entire part, you can see it has collapsed. So this is a very vulnerable area, and still people don't regard it, and as a result you're experiencing such events. So you can see all this area is completely covered by the soil which has come down. Then floods are of different kinds: seasonal floods, flash floods, urban floods, and those associated with cyclones. So seasonal floods is when you have in rainy seasons. That's why it is known as seasonal. So when you have a lot of rain for a long period of time, then there is a possibility of floods happening. Flash floods happen just in an instant, so that can be a result of cloudburst also. So there, it need not happen over a long period of time. It's just for a short period of time, a lot of water is coming down. So that is flash flood. Urban flood is mostly found in city or town areas where there is a lack, there is a poor drainage, like or lack of good drainage system. So then urban floods will happen, and then those associated with cyclones, because cyclones also bring a lot of rain with it, right? So then that can also eventually result in floods. Then example which the professor has also discussed in the lectures is the 2008 Bihar flood, which was the result of the river avulsion of Kosi River, river channel avulsion of Kosi River. So what happened is that initially the Kosi River was flowing in this path. Okay, so each river has a river channel. So people, because this floodplains of rivers are very much fertile, so people will stay close to the river channels, right? So people were staying in this region, which was closer to the Kosi River channel. But what happened is that in 2008, due to some reason, like possibly due to some tectonic activity, what happened is that it shifted in this direction, like over 60 kilometer, and the river started flowing here. So it shifted from A to B. Over 60 kilometer, it shifted. So the people who were staying here, they didn't anticipate it. So they thought Kosi is flowing in this direction. So even if flooding happens, they are not going to be affected by it. But unfortunately, what happened is that the Kosi River, its channel avulsed, or it shifted, and it came in this path. So a huge loss happened, like to life and property. So people were stranded because of the water and all those things. So this was a very unexpected event, but yeah, it did happen. So that is all that I had discussed today. And then I had discussed about plate tectonics. So if you have any questions, please feel free to ask. We still have time. So if anybody has any question, please feel free to ask. And if I'm not able to give you the answer right now, I can also go through the material and then I can discuss it in the upcoming week. So are there any questions? Yeah. Yeah, yeah. Please tell. Mm-hmm. Not exactly for earthquake, but yeah, you are right in case of landslide. Yes. When you, the problem is that these hill slopes, they are already not very stable. Okay. So you know, right? If you have a slope and you put a ball on top on that, it will go down. So that is a normal thing that you understand. So what happened is that when people start building, constructing their homes or whatever, like buildings over there, without considering the slope or how unstable it is, then that will eventually result in landslide. So that is something which we can avoid, but unfortunately people don't do that. Earthquake is mostly related to this tectonically active regions, like I said, no, like where you have plate margins. Earthquake is mostly associated with that rather than this. But yeah, you are right, a landslide is because of this. Yeah. Huh. Hmm. Events. Yeah. That can happen, But what I'm saying is, it can directly influence landslide events. Earthquakes can be influenced, but that is a kind of an indirect effect. Not directly, but indirectly, it can also result in earthquake because there is a change in the material that is overlying. That is true, but direct effect is on events such as landslides. Oh, thank you. Any other questions or any like if you have any suggestions also, I'm very much happy to take it so that accordingly I can alter it in the upcoming sessions. Do you have any questions? Okay, Arman. Okay. See what I'm trying. What Zephrul, like what he said is that, like if you, like for instance, these mountain slopes or hill such areas, people for constructing buildings or anything, you know, right? How humans are impacting the nature. So when they do that, you know, when they remove this material from such slopes or such lands, that will completely affect the equilibrium of the entire surface. Okay, so you know that earth is always in an equilibrium state. You have hills, accordingly you have valleys, so that is kind of maintained. So in this case, what happens is that if the slopes are affected, so in such situations, mainly it can trigger this landslides. So that's mainly human induced. So although naturally landslides can happen, but because of human effect on this, that kind of accelerates such events, and it results in this landslide. And what he said is that in case of earthquake, what I would say is it does not have a direct effect on the earthquake, result in a directly on the earthquake, because earthquakes are mostly associated with tectonic activities. But at the same time, I would say that there is a disbalance that is happening. Like people are taking some material from one region, and then like that difference is happening. So that can also lead to such events, but it's not a direct influence. Like it can contribute, but it's not directly, because earthquakes are mostly associated with the tectonic plate boundaries. I hope I have made it clear, but if you are not clear with that, in the upcoming lectures where sir is discussing the earthquakes, I think it will be much more clearer to you. We can discuss in those problem solving sessions also. Okay. So anybody else, like any questions, anything? Like if you are not feeling comfortable asking me like this, like through your audio, you can also message in the chat box. Yeah, yeah. Yeah. Mm-hmm. Yes. Hmm. Yeah, yeah. But I'm sure like you will have a lecture on this flood part also, because this is an introductory, I think this is your second week, right? So in the upcoming weeks, you will have a discussion on this floods. And at that time, I will definitely focus on this urban floods also. Yes, like at present, it is very important. So yeah, we'll have a discussion on that. Okay. Any other questions? Anybody? If you don't have any questions, then I can end the session. But if you have, yeah, you can feel free to ask me. That's all right, Arman. Like, if you have any doubts, like I think in the subsequent weeks they will share this recording also, because I have recorded this session. But if you have any doubt, you can ask me in the next week also. All right. So, shall I end the session? Okay. Thank you. Okay. Do you have any questions? All right. So, I'm ending the session. I hope you were able to understand whatever I said. Uh, Rohini, like I have, the session was is almost concluded. But if you have any queries, like I can continue. Do you have any question? I couldn't see if you had joined in earlier or not. So if you have anything, you can ask me. All right. I hope I'm not sure if I'm audible to you. Um, if you have any queries, please like feel free to ask me. I'm recording these sessions also, so you can go through them again in the YouTube channel.